Hello and welcome to this NASCAP knowledge base video. In this video, we'll explore the settings option in NASCAP and show how these switches allow you to modify the calculations the model uses to predict intake and growth. Let's take a look. All settings are accessed from the Settings tab. Within this tab, there are two options, Switches and Palette. In this video, we'll focus on the switches. When you click on switches, a new window opens that you can resize as needed. This window contains a series of checkboxes, each controlling a specific calculation or display option in the model. Each switch is shown in a row with its name, the checkbox, and a brief description of its function. We'll go through these switches in order. The first switch is Use Targets. When this box is checked, NASCAP evaluates performance relative to the targets you've defined. These targets are displayed on the performance screen in the row of summary boxes at the top of the window. When targets are enabled, each box is color-coded. Green indicates the results are within the criterion of the target, yellow indicates it's within a second criterion, and red indicates it is a final criterion away from the target. In this example, most targets are being met, but liquid intake is below target. We're feeding about 50 kilos instead of the target of 70. And dry matter intake from 0 to 4 months of age is also below the target. Additional knowledge base articles explain how to set and adjust targets and how to change the criteria for the color coding. Clearing this checkbox simply turns off the color display. The next switch is Show Body Weight. This controls the large graph on the right-hand side of both the performance and scientific screens. When this box is checked, the target body weight curve is displayed. If it's unchecked, the target line is hidden and only the simulated body weight is shown. This allows you to easily compare actual versus predicted growth to the target. The next three switches, Gompertz, Polynomial, and Fixed, control how target average daily gain is calculated. Target average daily gain is critical because it determines the energy and protein requirements for growth in the NASCAP model. The Gompertz option uses a classic Gompertz growth curve, which is widely used to model animal growth. From this curve, the model calculates target body weights and the corresponding average daily gains over time. These targets tend to be somewhat lower early in life and increase gradually later. The Polynomial option uses growth curves derived from Penn State University body weight data. The model calculates optimal body weights at each age and then determines the average daily gains needed to reach those targets. Like the Gompertz option, polynomial targets start lower and increase over the course of the simulation. The Fixed option uses constant target average daily gains, with one value for pre-weaning and one for post-weaning. This approach is most similar to the traditional NASA model, where growth targets are fixed rather than changing with time. The next three switches relate to dry feed intake prediction. NASCAP offers three different intake equations. The first is CAN-DMI, based on dry feed intake prediction equations published by Quigley and colleagues in 2021. The second is NAS-DMI, which uses the intake model from the NASEM Nutrient Requirements book. The third option is based on an equation published by Silva and colleagues in 2019. That equation applies only to pre-wean calves, so after weaning, NASCAP automatically reverts to the Quigley model. You can select any of these three options and the model will immediately recalculate intake and growth. There are very significant differences among the three models to predict dry feed intake, so use care in making your decision. The next group of switches adjusts digestibility assumptions for liquid and dry feeds based on published research. The first two switches adjust liquid digestibility for energy and protein using relationships reported by Quigley and colleagues in 2021. That work showed that digestibility of liquid feeds is lower during the first 30 days or so of life and gradually increases with age. When these switches are enabled, you can see small changes in digestibility curves on the scientific screen, particularly in the graph showing liquid feed digestibility. These changes also affect predicted performance. In this example, final body weight declines from about 145 kilograms to 141 kilograms when both liquid energy and protein digestibility adjustments are applied. By default, these switches are turned off. The next switch adjusts liquid protein digestibility for vegetable protein sources. If a milk replacer contains significant vegetable protein, indicated by the higher crude fiber or NDF values, the model reduces protein digestibility accordingly, using values from the feed composition. The next two switches adjust dry feed digestibility for energy and protein, based on work published by Quigley and colleagues in 2020. These studies show that digestibility of dry feed is lower early in life, before rumen development and before calves reach about 15 kilograms of cumulative NFC intake. When these switches are enabled, digestibility values can range from roughly 40% to 80%, depending on age and intake. The Adjust MCP switch modifies the contribution of microbial protein. When enabled, microbial protein contribution is calculated and increases with age and intake based on relationships described in the 2021 NASEM publication. If the box is unchecked, NASCAF uses a fixed rumen development protein value instead, based on the calculations from the 2021 NASEM calf model. The next switch limits dry matter intake based on NDF intake, capping intake at about 1% of body weight as NDF. This relationship comes from heifer research by Hoffman and colleagues. Because calf diets rarely reach this NDF level, enabling this switch usually has little effect. The Is Jersey switch increases the net energy requirement for maintenance by 10% for Jersey calves, based on research from Virginia Tech. Enabling this option increases maintenance energy requirements and affects predicted growth accordingly. Finally, the Striped Pages switch controls the appearance of tables in the report. When checked, tables are displayed with alternating row shading. Clearing the box displays plain tables. Well, that concludes our overview of the setting switches in NASCAF. These options allow you to tailor intake predictions, digestibility assumptions, and growth targets to better reflect your management system and research preferences. Thanks for watching, and be sure to explore other NASCAF knowledge-based videos to learn more about how to get the most out of NASCAF.